Hello, everyone, and welcome to this webinar on Feature Store for SageMaker. This will be hosted by Mr. Jim Dowling, CEO and co-founder of Logical Clocks, and myself, but I'll be just here at the beginning and at the end. We will also host a Q&A session at the end, and our software engineer, Moritz, will be answering some of your questions in the chat if you have any, and do feel free to have. And I will now give it to Jim, and see you.
All right, thanks, Lex. Let's get going. I'm going to share my screen. I see people are still joining, so what I'd like to remind you is that this is a new form of webinar. We have somebody on chat, Moritz, who's one of the main developers on the Feature Store. He can answer your questions live, so as we progress, you can just write your questions in chat and expect a prompt answer from Moritz. So again, welcome to this webinar. We're going to talk about the Hopsworks Feature Store and in particular, how you use it as a SageMaker customer or SageMaker user. So my name is Jim Dowling and I'm a co-founder of Logical Clocks. Logical Clocks, we're a company based primarily in Stockholm, Sweden, and we have offices both in the Valley and London. And these are some of our key people. But what we're going to talk about today is how you as a SageMaker user go from maybe what you're currently doing, which is you're writing ad hoc scripts and jobs for creating training data sets or feature engineering, and then how you move from there to sharing feature engineering jobs. And ultimately, if you go to a feature store, to have not just the sharing of feature engineering jobs and the sharing of features, but managed environment for both online and offline data. So what that means is data or features for training your models, and also features for serving your models. So that's when we say offline, we typically mean the training data and the batch data for those features. And then online, we typically refer to the features that will be serving to operational models. So online applications that need feature data in real time. Okay, let's get started. So many of you will not have heard of feature stores before, but you may be curious. And you may be curious because you've heard that most hyperscale AI companies, I think it's not an exaggeration to say all hyperscale AI companies have a feature store. And Uber have talked about theirs for a good number of years, 2.5 years now. But many others such as Airbnb, LinkedIn, Twitter, Netflix, Facebook have talked publicly about their feature stores. So Hopsworks is the world's first fully open source feature store. It was released at the end of 2018. And it's now the only enterprise feature store that's out there and available. And it's also the only SaaS feature store. So software as a service. It's a managed platform on AWS. It's the only managed feature store service available in the market today. So there's a good reference here, featurestore.org, where you'll find a lot of videos and material about feature stores that are being used in production today. So I'm going to start at the start because we often have data engineers on these type of talks, not just data scientists, and they have a picture of what a feature is. They might think it's a column from a data warehouse table. Maybe it's some data that's coming from a file on a data lake or an object store. But in machine learning, we have a more specific definition of a feature. It's something, a measurable property of something you want to use to help you make predictions. So it's information. It's a piece of information that will help you make a prediction. Maybe it's the number of free rooms in a hotel. Maybe it's a pixel in an image, a sound wave. But often what we find is if you're working with tabular data at the back end, so you have relational databases and data lakes, we typically take that data and we compute often aggregates over that data, maybe means, sums, min, max. If we're working with real-time features, often we have windows. So we might want to know the number of transactions a user has executed in the last hour or in the last 10 minutes, maybe the number of items they have in their shopping cart or the average number. We often have complex features. So complex features are features that require a lot of computation to get some sort of derived representation of something that's maybe very complex, like you might have a document or a sentence or a word. And we have things called embeddings. They're a way of computing high-dimensional vector representations of words, sentences. We use this as well for money laundering. There's a nice webinar and a blog post about that on our website. But features can be very complex and they can be very simple. And they're the main input to our models. It's the data that we take into our models. And features are numerical, is the other point. So a data engineer might look at this table where we have an array of feature values, and we can see that they'll say, oh, look, these are numbers. I've heard that features are numbers. Everything's great. A data scientist who maybe have more insight will say, yeah, they're numerical, but if I look at the last row here, I can see we have quite a wide span of numerical values. Maybe that will lead to numerical instability in the algorithm I'll use to train a model. So what I'll do is I'll compute a feature. I'll normalize these features. I'll normalize these numerical values. That means I'm going to squash them into a range between either 0 and 1 or minus 0.5 and plus 0.5, and I'll use an L1 norm to do that. So feature engineering is about these type of transformations. We take our input data, maybe it's strings or varchars, and we one-hot encode them. Maybe it's numerical data, we normalize or zero mean it, and it requires some sort of code. So if you've read up about feature stores, what you might be aware of is that there are what are called domain-specific languages for Michelangelo by Uber and Airbnb, Zipline. Our platform does not use DSLs. We use a general purpose programming model based around the data frame API. And the data frame API is supported in Pandas. Many of you will be aware of Pandas, but also in Spark, PySpark, so in Scala and in Python versions of Spark. But in this example code, we can see some PySpark code, which is just showing you how you would do an L1 normalization on a data frame and a particular input column. So this piece of code is our feature engineering or our transformation code, and that's what we'll use to actually take our raw backend data and turn it into features that will be ready to be consumed by machine learning models later on. So the gap I'm trying to identify here and point out is that the data engineers who really have tremendous skill in being able to collect the data, doing the 80% of the work that we say machine learning is about, is collecting the data, transforming it, cleaning the data, and getting it from all these back-end systems. And often the data may be in databases or data lakes. It will have schemas, it will not have schemas, it will have missing values that need to be imputed. But we need to also transform that data into numerical data that we typically use in machine learning. So arrays of numbers, NumPy arrays, maybe it's going to be TensorFlow record data. And we need to take varchars and one-hot encode them, and we need to make our numerical data usable in the models we're going to train. So the feature store is going to try and close that gap. The other problem that the feature store will address is a very interesting one, which is duplicated feature engineering. If you have many different teams in your organization who are computing features, and maybe they're computing similar features, maybe they're using, for example, BERT, which is a well-known pre-trained network for natural language processing, and maybe they have some code to take documents and transform it into the features that the pre-trained BERT model expects. Maybe that code would be useful for other departments or other groups or teams in your organization, and it would be great if you could share that feature engineering code rather than re-implement it in every different department. The other problem that we'll look at today for the feature store is how do we ensure that the code that we use, that we write to compute these features, is consistent when we're training the model, but also when we're using that model in an online application. So our online application, we can see at the bottom here, is written in Java, and our training is done in Python. So if we want to re-implement a feature in Java and in Python, there is a risk that it will be not the exact same implementation, and therefore the features will be slightly different, which will lead to problems when we try and actually use our models to make predictions. So what the feature store gives us instead is the ability to have a central place, that's this one here, where we're going to compute our features and transform our data into features in a pipeline, and that will feed the data, materialized features, into the feature store. And now when we need to actually train models, we will get those features from the feature store, and we're assuming it's supervised machine learning, so we'll have some labels for the data, and then after some training, we'll have a model. And in the case of using the feature store for serving, what we'll see is that the online feature store can be used to get features at low latency. And then we have a trained model which we apply to those features, and that will give us predictions. So this is the, the way the feature store will handle the problem of making sure that features are consistent between training and inferencing. We will, as far as possible, ensure that there is a single pipeline for computing features. So the Hopsworks Feature Store is one of many different feature stores out there, and it builds around 3 different concepts. So I'll introduce the concepts first so that we're familiar with the underlying implementation. So the basic concept in our feature store is the notion of features. So if we take, for example, the Titanic data set, which is a very well-known data set in data science, there's this data set basically is used to help train a model to predict if a passenger has survived on the Titanic or not. And there are a number of features. The name of the passenger, probably not great for predicting. The sex is quite a good feature for predicting. And whether they traveled in first, second, or third class is also quite good for predicting. So we can imagine that that group of features came in, it was imported as a file. And our feature store, some historian came along and said, well, I researched the bank account balances of all the passengers on the Titanic, and I'm adding them to the feature store from a different source. So now we have 6 features in total at the bottom. These are our 6 features. And the data scientist goes to the features. We want to reuse these features in different models, and models will have training data sets. So the data scientist will come along at this point and say, okay, I'm going to join together a bunch of these features, and I'm going to join the bank balance, which we saw down here, with these other features. And I'll get a new training test data set up here, which is our 3rd abstraction. So we have the features are stored together in groups, and then training test data sets are basically lists of features that we join together to create a training test data set. So what that means is we're going to take these features and materialize them. And this is typically what you do. Now you can get this out as a data frame and you work directly with the data frame, but often if we're working with, for example, deep learning, we'll want TF record or we'll want NumPy files. You then decide where you're going to store, where you're going to materialize this training data. And today we'll put the data in S3 in a bucket. So in SageMaker, we'll pick a bunch of features, we'll join them together, and then we'll save them in one of these file formats in an S3 bucket. And then from the S3 bucket, you can go ahead and use SageMaker to train in a different notebook, potentially, to train your model to predict whether the passengers survived on the Titanic or not. And hopefully you will have slightly better accuracy than the original one. So the last point to mention here is that all of these things are versioned. We have these 3 abstractions, the features, the feature groups, and the training test data sets, and their versions. And this is needed for reproducibility of our models and also for governance. So we actually, if you support your training test data set and your feature groups as hoodie, or in particular the feature groups as hoodie, not necessarily the format of the training test data, well, then you're also able to reproduce these training data sets exactly at the time they were created. And I'll talk a little bit about that later. So we're still in the introduction. So what are these things called feature groups? Well, feature groups, you can think of them as being groups of related features that will get ingested from the same backend system, but maybe they'll get ingested at different rates or cadences. So you might have real-time data, and your real-time data up here might be coming from a user inputting information into a web page. Maybe they want to make an insurance claim, and that data gets into the web page. So we need to somehow convert that or transform that data into features. And then we'll also have event data coming in maybe from Kafka, SQL databases, so online transaction processing, operational SQL databases, data warehouses, and data lakes. So some of the features will have very low latency. And if we look at an example here, we can see that we might have, and these are use cases from our customers. We have one customer who needs very low latency real-time feature transformations, but we also have then at the other end, we have these batch applications that maybe once a day or once a week or even once a month will push updates to the data that's coming from the data lake. So different types of features will have different latency requirements in terms of how often they're generated. But what we want to do is make them all available in a single platform, a single data platform called the feature store. And the feature store itself will be used by 3 different backend systems that we're identifying. One is these online applications that maybe need to look up some historical features. They might want to look up, you know, your history. How many times have you logged onto this website in the last month. You know, what's your shopping history been like? What's your credit score like? Information not available in the app, but needs to be looked up at low latency. Also, you want to use the feature store data scientists who want to train models with the features that are in the feature store. This is a pretty common use case. Your data from your backend systems is being aggregated as features in the feature store. Now the data scientists can go along, select features, create training and test data sets, and train models with them without having to go back to the backend platforms to get the data. And then the third use case is for analytical applications or batch applications that maybe need to use models to make predictions. So they can go to the feature store to get data without labels, so features without labels, and then they can apply models that have been trained to make predictions and output data. So those are the three main use cases that we have for users of the feature store. And I'll go through the online applications and training examples in a bit more. So the issue with the feature store is that we need online applications with low latency access to data, and then we need to have very scalable amounts of feature data. And we have one customer we talked at the Spark Summit last year, Swedbank. They had 40 terabytes of transaction data training their model. So we need a database that's both scalable, but also low latency. And in fact, there aren't really many databases that give you both that OLTP for the low latency and OLAP support for the analytics and scalability. So what our feature store and what most of the other feature stores in production do is they have two different databases, a dual database system. We call the low latency database system the online feature store, and the scalable SQL system the offline feature store. Now, when we break up the feature store into those two components, that means that pushing data to the feature store, actually you decide, well, which database is this feature going to? Will it be consumed by online applications, in which case I push it to the online feature store, or will it be consumed by batch or training, then I'll push it to the offline. And you can see there are other examples where we need to push the data to both the online and offline feature stores. So that's where we have this notion of, we said earlier on, we want to have a single pipeline to transform our data into features, and we want it then both to be available for inference and for training. So we push to the online and offline. We have a single feature pipeline, but the data is available both for serving and for training. So that's very abstract, but in our particular platform, I mentioned earlier, we have a data frame API to the platform. That's we ingest data in our features into the feature store in groups as data frames. So they can be Pandas data frames or Spark data frames. And what we can see here is that we have our event data, for example, user clicks come into a Spark streaming app, and then it materializes the data as data frames to the feature store. You can also have a Python application with Pandas data frames that it can upload to the feature store. So you can create feature groups, and they can also update feature groups. And we can also have Spark applications or PySpark applications. In the case of very low latency real-time features, there is always going to be a use case where we can't transform the features and then the online app can retrieve them in the end-to-end latency that we need. In this case, we said 2 seconds. So we won't have time to materialize the data in the feature store and pull it out within 2 seconds. So we can use platforms like Flink to transform the features and get it to the data in less than 2 seconds. But at the same time, that Flink application can still materialize that data to the feature store to make it available later on for training, if you want to do so. Okay, so the real value of the feature store in this case is the complexity of managing online and offline databases to serve and train your serve features and training data has been simplified by providing a single unified general purpose API, the data frame API, and making the programming model more manageable for both data engineers who are going to be ingesting data and data scientists who are going to be using the feature store to create training and test data sets. So let's have a look at some code to make this a little bit more concrete. We have here an example of some Spark or PySpark or Pandas code. It's pretty generic code here. What we're basically doing is we're going to create a data frame, and you create a data frame by connecting to your backend system. So maybe it's to your database, to your data lake, to a distributed file system, and you read up that data into a data frame. And then you will do your feature engineering on the data frame, and we saw an example of the code that we would have for that type of feature engineering. And of course, there are many libraries available out there to do feature engineering with. As I said before, this is a general purpose platform, so we don't have a DSL specifically here, but you can use great feature engineering platforms like Feature Tools, or PySpark has very nice feature transformation libraries. And Pandas, of course, is extremely widely used. But once you've done your feature engineering and you have a data frame that you're ready to ingest to the feature store, you can just create a feature group, give it a name. And of course, there are many other parameters here, such as, do we want to go to the online, and is the online going to be true, as well as the offline feature store? Do we want to have a version for this? Or do we just take the next version? And so on. So that you can look up the API for this. It's available online. We have documentation for that. So what we've looked at now so far is basically, we can see this part where we're ingesting data into the feature store, and we're going to ingest the data as data frames primarily. And we've talked already about the users. We have the online applications. We have the data scientists who want to train models by joining features, and then we'll have our batch application. So let's look at an example on this side of the feature store. Okay, so this is a data scientist, and the data scientist would like to join together a number of features from different feature groups, potentially, and create some training data to train a model with. So what the data scientists, and particularly a SageMaker user, could do is within their Jupyter notebook, they could write code that looks like this. Firstly, we have to import our library. And in this case, the API, we have support currently for a flat namespace of features that we can join. There is a query planner that will look for a common join key if these features come from different feature groups. And in this case, they do, because the bank balance is from a different feature group than the other Titanic dataset features. So it will use an identify name as a common join key. It looks for the largest overlapping set of common join keys between feature groups. You can, of course, and in many cases, you will need to specify explicitly what the join keys are. We will have a new API coming out soon, which makes this slightly more Pythonic and adds scope, because often we can add scope to this as it stands, but we're going to make the addition of scope a more encouraged programming practice. So what we get back by joining these features is a data frame. And this data frame we can work with directly, so I can train a model in that takes this data, this Pandas data frame or PySpark data frame directly. What I can also do, and what we often do in deep learning, for example, is that we'll materialize this data frame as a training data set. So we're going to store this data as TF record training data. We can give it a version. It will be an immutable training data set with a particular version. And this is the data frame then that we're passing in to do it. And the name of the training data set we've given there, Titanic_training data set. Okay, so this is how this would typically be versioned code that you could write in a Python program or a notebook. You can schedule it to run before you get to work, and you know that new data arrived in the feature store overnight. You'd like your training test data set to be ready to go when you get to work. You run it in the middle of the night, and when you get to work, you've got the new training data to run on. So this is typically going to be a standalone stage in any pipeline. You might often do filtering and things like that. You might filter out based on time or time intervals. And you can do that very easily if this is Spark or Pandas code. But if we move on and say, okay, well, the data scientists can use the feature store in that way, what about these applications? We have these online applications, and what the online applications want to do is to get features with low latency because they want to make predictions. So I can give an example of a model that we've worked with before, where we have just a small number of features arrive relating to money being transferred and the bank accounts involved. But we don't have all the historical information about the number of transactions the user has done in the last 15 minutes, the credit scores of the people involved, the geographical locations involved, all those features that you would like to use to help make better predictions are not available in the online application, so we go to the feature store to get them. So in our case, what we do is we have a JDBC API to our online feature store, which is MySQL cluster. And given the name of your training data set and the model, we just need the actual training data set, but the model is typically a one-to-one mapping to the training data set. We ask the database for a prepared statement, and the prepared statement will be basically the list of features that you need to get to build up your full feature vector. The online application supplies the keys being things like the user ID, entity IDs, maybe timestamps, bank IDs, and things like that. And the database will then join together all of the different features from the different, in this case, tables. So the data frames get mapped to tables in the database, and will give you back the application a feature vector. And from that feature vector, the application can then send it to a model being served over the network. So typically in online applications, we don't embed the model inside the application unless latency requirements mean it's necessary. And we do that typically because we want to separate the life cycle of the model from the application so that we can update the model maybe more frequently than the application. So TensorFlow model serving server, you can have Flask servers for scikit-learn and PyTorch. And of course, this can use SageMaker model serving as well. So what's interesting about our platform is the database we're using for the online feature store is called MySQL Cluster. It is highly available in the cloud, so you can use it, make it highly available across availability zones. So if one of these availability zones decides to crash, or even if two of them, because it's not a quorum-based system, it's using actually a non-blocking two-phase commit protocol. So if you just have one of these particular availability zones alive, but then the application can still retrieve the feature vectors. Now, there are other feature stores that use databases. I loosely use the term databases, caches like Redis. And Redis is nice as a cache, but for important business critical information, such as features that help make predictions in your operational applications, you really want to have a transactional, highly available database retrieving, storing, and managing your features. Okay, so let's put the feature store in context. So we've talked a bit about the use of the feature store, how we ingest features, how data scientists can use it to create training test data, and how online applications can use the feature store. The pipeline is the unit of abstraction we have for building models. And your pipeline may look different. You may do your feature engineering in platforms such as Elastic MapReduce, or you might do it in Databricks, or you could even do it in SageMaker, or in our platform, Hopsworks as well, which supports Spark and Python natively. So you do your feature engineering somewhere, and we can see that somewhere is here. It's going to be some program, and we're assuming that your feature engineering will involve building data frames from the backend platforms, and it will ingest the data into your feature store. So you can do that in SageMaker. I'm not going to demo that today. I think the primary use case for SageMaker is for data scientists rather than data engineers. So what the data scientists will do when we go to the feature store is, and I presented this workflow because it's not a very common or well-known workflow, is that often the first step is just to select the features and materialize your training test data. Sometimes you're working with smaller amounts of data. You can get a data frame in pandas and pass it directly for training. But typically when you're using expensive GPUs for deep learning, you don't want to spend time, for example, joining features together to create training test data frames, because you're going to be paying for the GPUs while you're doing that join. And it's often not a stage in the pipeline that's latency sensitive when you're training models. So first stage is often selecting features, materializing the training test data, and then you have a model that will work directly on this training test data. You're going to train that model. You may use one GPU, lots of GPUs, or no GPUs. And then after that, you obviously want to evaluate your model, make sure it's good enough to publish it in a model repository. At this stage, of course, you can, our platform is a modular platform. You can use SageMaker for all of this, and that's what we'll do a demo of later. We can do it also internally on the platform. So once the models are available, then the next stage is, of course, serving your models, either for batch predictions, in which case you can just read the models as files and incorporate them embedded in your Spark applications, for example, But when you're using online applications to make predictions, you will typically use a model served over the network. And as I mentioned already, the online feature store gives you the ability to retrieve feature vectors at low latency to build your feature vectors to make online predictions. Okay, this is for the operations people here. What I will demo today, you can do VPC peering if you want. I won't show that in the slide, but today what I'll demo is just a SageMaker notebook starting in the same VPC as a Hopsworks cluster. And we'll actually even start them within the same subnet. So what we will need to do is just expose the feature store from Hopsworks so that it is accessible from our SageMaker notebook. And then accessing other services, so being able to access S3 or a data warehouse or an operational SQL database, primarily you will still be using IAM roles as a security framework for accessing those external services. So we're going to use the IAM role in our SageMaker notebook as well to retrieve an API key for this Hopsworks feature store and to connect to it. And we'll look at that in the demo. So a little recap on the feature store. We have this offline feature store, and I didn't mention it is Apache Hive. In fact, in the managed version of our platform, the files and data for this scalable feature store are stored in the bucket in S3. You can configure the feature store to say, okay, store the file system data. Our file system is called HopsFS, but its data can be stored in a bucket in S3 for obviously improved cost, but also scalability reasons. The online feature store is based on MySQL cluster. We provide a JDBC API primarily for serving clients because A, it's secure, and B, it's widely used, and C, it is low latency and high performance. Then the platform as a whole, Hopsworks, has support, we'll see, for things like a secure multi-tenant, a project-based multi-tenant security model. There is encryption of the data in transit and also at rest, and extensive support for governance and lineage and provenance if you're using the platform for training. But we won't go into too much details on that today. So I'm going to move on to is a demo, and we'll have a look at the feature store itself. And that's within the Hopsworks platform, so Hopsworks UI. We're going to look at how we connect SageMaker to that feature store. And then we'll do an example for connecting to the feature store and creating a training data set in a bucket in S3, which is a common use case. Because then once the data is in S3, another SageMaker user or notebook can be used to train models with that ready-made training data. And the 80% of your work that you would have done cleaning up and you know, transforming that data into features is now saved, and you can use your time to make great models and train high quality, high performance models. So there's different ways of trying out Hopsworks. It is an open source platform. It's AGPL v3 licensed, and that's the Hopsworks community version. And you can go to our documentation, hopsworks.readthedocs, to find out more information on how to install it. We have a version of Hops called Hopsworks Enterprise. It's used both in the cloud and on-premise. And Hopsworks AI is the managed version of Hopsworks Enterprise. So it's available only as a managed platform on AWS currently. And that's what we're going to use in the demo today, Hopsworks.ai. It's the easiest and fastest way to get started on the AWS. There are a few features in Hopsworks Enterprise and Hopsworks AI. Integration with Kubernetes for serving models, but also for running Jupyter notebooks. If you're running Active Directory as your IDP, then we can connect in directly, as well as LDAP or OAuth 2, and also support for GitHub is only in the enterprise version. So the platform is available at hopsworks.ai. I'm going to go there to do the demo. But you can follow us on Twitter at Logical Clocks, and we are an open source platform. So if you go to logicalclocks/Hopsworks on GitHub, you can see all the code, and there are lots of example notebooks there in a repo called hops-examples. So let's move over to the demo. Now I'm going to use Hopsworks AI. I've already created an account. You will need to sign up here and fill in the form to create an account. And what I'm going to do is I'm going to just first sign in. I'm just going to follow the documentation. So if you search for hopsworks.readthedocs.io, you'll see this getting started. We have Hopsworks AI, And we also have SageMaker Quick Start. So that's where I currently am. So these are the steps I'm going to follow so that you can go back and look this up later on if you get stuck somewhere. So the first thing we want to do is deploy the Hopsworks and its feature store. And then we're going to generate an API key in Hopsworks, store that API key in the secrets manager. I'm not actually going to show that because it would show my AWS account ID. So I'll leave you to fill in that step yourself. And then we'll have a SageMaker notebook where I'll just show you the steps that you need to install a library to connect to Hopsworks, and then you need to use this. We're going to use the IAM role of the notebook to download that API key from the AWS Secrets Manager. And then there's some next steps if you follow that about how to proceed, which I won't cover now. But there's a feature store tour notebook in the platform. There are examples on Hopstash examples on GitHub repo. There's I think about 30 or 40 feature store specific notebooks there. There's a few on AWS SageMaker. But let's get started. So this is Hopsworks AI. I have created a cluster already. That's this one we can see here. I'll just point out, this is the cluster that I've already created. And you can see it's running. And I access it at this location, and we can see it. And that's my account that was automatically created in the password. And we can do things like backups of this cluster. We can stop the cluster, and we can also terminate it if we don't need it anymore. But creating a cluster does involve, if you create an account, you'll have two options. One is to just log into a demo Hopsworks cluster, and you can do that, which is great. If you have an AWS account and you are able to give your AWS account privileges to allow Hopsworks.ai launch a virtual machine in your AWS account, then this is the best way to get started. So to do that, you need to, maybe you might have to contact your own IT, but what you might possibly need to do is follow these steps, or maybe your IT can do it for you. So you need to create something called a cross-account role and add an inline policy to that cross-account role and store the cross-account role. And then we're going to use this particular ARN and copy that in here into the settings to make it, to configure it such that we're able to actually then launch the cluster in your AWS account. This is very similar to how Databricks set it up. If you talk to your IT, you just tell them this is the same as something like Databricks. Okay, so I've opened this already. If you click on the link, it'll open a new. I had this one already open here. So it's this cluster is in Europe, London, I believe. So I'm just logged into the Hopsworks platform. So what we can see when we log in here is that we have this notion of projects. Now the platform is, as I say, modular. It's not just feature stores, but we typically might have a feature store, which is a, let's say a dev feature store. Let's call this one dev, and we don't need all of the service necessarily. We don't need notebooks, we might need Hive, and we can even maybe remove and keep jobs. Maybe we want a job to create that feature store. But basically, you can have these projects as they're equivalent to GitHub repositories. They store data, users, and code. And the feature store, you can have a development feature store, a production feature store. Okay, I've already done this, so I'll just skip that stage. But you can have development feature stores, production feature stores, and you can even share then feature stores between these different projects. So that's a typical way of doing DevOps, where you would have a development feature store that you would publish features to first, and then when you're happy with them, you would point your pipelines at the production feature store to ingest those features into the production one. So I ran this demo or this tour already. So we have these things called tours here. So I ran the feature store tour earlier on, and I got this demo feature store project was created. So this is, you can think of this as being just a feature store. There are a number of microservices here on the left. We have Jupyter Notebooks, we have jobs. This was a job that was run by this particular job here. It's a Spark job, I believe, was run when I created the project. So the tool would run this job to create some feature groups and features for me. This is the feature store. I'll look at in a second. We then have some other services for machine learning. We won't look at the file system is here, and we can see that there's training datasets folder where I have some training datasets created. We have the feature store itself, and then we have some other logs and notebook folders here. And then another thing to note is that you can add or remove members of your project here and give them roles. We have data owner and data scientist roles. A data scientist is actually sandboxed inside here. So if you have a user who's a data scientist in this project, they cannot copy data out of the project or even read data from other projects that they're members of. It really is project-based multi-tenancy. If you're doing feature engineering in our platform, you can install libraries in Python here. You can see we have a bunch of libraries installed here already, and you can search for new ones and install them in this project. So those libraries will be specific to this particular project. So let's have a look at the feature store here. This is the feature store. I mentioned earlier in the talk that we have three abstractions. We have features, we have feature groups, and then we have training data sets. So there are three abstractions, and we have three tabs for each of them. I'll go through them one at a time, but we'll start by looking at the feature store details. So this particular feature store has 27 features spread out over 7 feature groups and 2 training data sets. And as I said before, you can share feature groups between or feature stores across projects. So if you have a sensitive set of features, you can have a feature store with just that sensitive data, and then it can still join features with the production feature store if needed. And then we have some more details, internal details. So let's, before we look at the 3 abstractions, let's also look at the storage connectors. I've created one already, a storage connector to S3 bucket. So I basically just put in the name of the S3 bucket. In this case, it's using the IAM role in the enterprise version to do access control to that bucket. And my SageMaker instance will be able to read and write to this particular bucket. And also this Hopsworks instance, when I created it, is given read and write access to this bucket. Because the Hopsworks instance, we'll see later on, is used to run a Spark job to actually create the trained data set. So SageMaker will launch a job here in Hopsworks, one of these ones like the team position Sage or the team position S3. These were jobs I ran earlier, which will join the features together and then create the training data sets in S3 or in our file system here as well. Okay, so we have storage connectors. If you want to use an S3 bucket, you create one of those, and then you can use that as a sink for your training data. But let's start at the feature groups. So we can see there's 7 feature groups here, and you can see that they're related to sport. We have players, and we have seasons and teams. And if we go over here, we can see on the More tab, we can look at the feature details. So here's some details on the feature. We can look at the schema for any given feature. We can see there's, in this case, we have 7 features, and they're all numerical features. And we can get a preview of the data in here, which is nice as a data scientist. You might want to see, okay, what does the data look like? This particular feature group is only offline, I believe. It's not online. And we have a job that was used to create it. And you can see API calls to get that particular feature group in your notebooks or programs. So this is also used as a way of doing exploratory data analysis. The data science can pick up this feature group and look at correlations between features in this feature group. And we can see there's no 2 features are too tightly correlated. We can look at clustering of the features, and we can see they're quite tightly clustered. And we can also look at descriptive statistics of the features. So these particular attributes of the feature groups, they're computed automatically. You can turn off the computation of them, but we will compute them for you so that when you ingest a feature group, that these become available automatically. And it's run typically as a Spark program. So we can see here we have the count, the number of rows in a feature group, or of a given feature, mean value, standard deviation, min, and max. And you can get the distribution of individual feature values as well here. So this is a nice way for data scientists to get started by looking at the features in the feature store, seeing, doing some exploratory data analysis on them, and they can see the individual features here. You can kind of do that as well. So here we also have the training data sets. And if you want, you don't have to write code to create training data sets. You can actually just do it in the user interface. So you can basically pick a bunch of features, put them in your, in this case, we can put them into this thing called a shopping cart. You can see I have duplicate features here. And then we can click on create training data set, and I can give it a name, something like team. The query planner did find a common join key, which was nice. I can give it a description, hello, and I can pick a file format. So I'm going to output the data in maybe NumPy or Petastorm, or so let's pick NumPy. And then I can say I'd like to store this in S3. in that particular bucket, and then I can go ahead and create that job. So that'll create a job that'll run in Spark in this case. And I can then create that. I need to give resources to that job. It's going to run in our cluster. So that was the create train dataset job at the top, and I can press run to run that job. That job will now get launched, initialized and launched in the platform. Okay, so that's the main user interface that I'll present for how users can navigate the feature store and explore what features are there. And even if you want to create train data sets, there are some other features in here that are useful in particular for Python developers. So you might have a feature group with data that you have ingested, but maybe you haven't done validation for all of the features. Maybe there's some features that have not a number, or maybe there's some values of features, some numerical values of features that are outside an expected range. Or basically, there are a lot of different predicates you would like to use to ensure that your data is what we call valid and correct for use directly in training models and also in serving. So one of the issues in Python is there's not great library support. There are a couple of libraries that have appeared out there. Great Expectations, really nice, but it's not supported in Spark. So if you're going to do your feature engineering in PySpark, there's not really great library support. So what we've done is we've added a nice user interface to allow you to write these or declaratively specify these predicates on your, in this case, this is a feature group. As I'm saying that this feature group has at least the size of 1 and a max size of 1,000. But I can take individual features. I can say the average attendance, its distinctness should be between whatever 1 and 100. So I can apply a lot of these different predicates on my feature groups, and I can create a job. And this is a data validation job. And that was this job that we had up here. So this job up here that we have, this data validation job, we can just put in a pipeline and run it, for example, after we have ingested a feature group. So we can, if we go, let's go to SageMaker at this point, and we can see how we're going to connect a notebook to this Hopsworks cluster. Okay, so I'm going to go back to the documentation so that we can see what the steps were. We wanted to generate an API key. Okay, let's do that then briefly. And then we want to store it in the secrets manager. So to generate the API key, what you're going to do is you can just go to the username up in the corner, click on settings, and then we have this API key here. And then I can just give it a name. So we'll call it just AWS, for example. And in this case, I'm going to give it job, feature store, and project scopes. So the API key is scoped, and it means it can only use the services or methods available within this scope. So it needs to be a little bit longer than that. So I can create the API key. It will only be available in this dialog, so I need to copy it. And then I would take that key that I've copied and make it available. I think I have it open here somewhere. This is the secrets. So this is the managed AWS Secrets Manager service. And you need to store a new key in here. In this case, we take it as another type of secret and we call it API key, and you paste the value in there. And then you click through next and give it a name. So in this case, I gave the secret name Hopsworks-role.SageMaker-Gym. This is actually the name of the role that I start my notebook as. I'm going to start a SageMaker notebook with a role of the name SageMaker-Gym. And that role, I need to actually then give it the ability to read the API key from this secrets manager. So what you do to achieve that is, do we have one open here? IAM roles, here we go. So I'm not going to, okay, we can skip around this maybe. So in your IAM role, what you need to do is you need to add an inline policy to allow it to read the contents of that particular bucket. Okay, so let's go to SageMaker. So now at this stage, we've gone through the steps of creating the API key. We've added it to the secrets manager service in AWS. And we've an IAM role that our notebook is going to start as that's allowed to read that API key. So then you can create a notebook instance. Now I've already created one that's running right now, but I can open it up so we can just see what's in here. So what we have in here is an IAM role that was assigned to it. And we can, let's go back, let's just open it directly. So that IAM role, again, should be the one that we saw before. Now I have this notebook actually opened already. You can see it's green, so I'll just switch to that tab. That's this one here, and I'll scroll through it and then we'll run it again. So the first step is that we want to install this library. So we want to install the Hopsworks Cloud SDK, and we did that already. And then we're going to import the feature store library from the Hops library that we just installed. The next step we need to do is we need to connect to the feature store. So this particular URL, or it's a domain name, is the domain name that we see up here. So we can just copy that from here and paste it into this connect method here. And then we're going to give the name of the project. So the name of the project here was demo_feature_gym100. And if I go back here, we can see that this is the name of the project here. So I can just copy it again from there. Hostname verification, we can just turn that off. If you're running the community version, you won't have a certificate for your feature store, probably. You have a self-managed one, so you'll need to set that to be false. And then we're going to use a secret store to get our API key. You can also get the API key token from a file or from the parameter store, which is also an AWS managed service. So, let's clear this up. So if I scroll through it, this example is creating some group of features and creating training data sets. I'll just clear all this. We'll restart the kernel, I guess. Restart and clear output. Okay, so this is actually a Conda Python 3 kernel. And if we run it again, we can see that that was already installed, that library, so that went quite quick. We import the library, and then we connect. And I had turned off the hostname validation is turned on, but that's okay because I'm using the managed version, which has a certificate. So now we can directly access the feature store. So in this case, we're asking for, we can ask for an individual feature and we can get some of the values for it. So this particular call is making an API call on the platform, and then it's running on the offline feature store. It's retrieving 5 values, the top 5 values from this particular feature group and this particular feature. So you can use it for data. So we can do our exploratory data analysis also from SageMaker. There are a lot more examples. If I jump over to, if we Google Hops-examples, and we Google Hops examples, if we go in here, we'll see that there are notebooks, and there are feature store notebooks, and there are AWS feature store notebooks. So if you open up this SageMaker feature store tour, it goes through the entire API. So in this case, you can see there's a lot more examples also in this case, we can take something like this line here, visualize a feature store group, and let's go back to our notebook and try that out. So let's just add a new cell. So this is using the same feature group names. So we can see that it then goes to the feature store and it retrieves the distribution of feature values for a given feature group and visualizes them for you. Now, the example I said I would cover is creating a training data set. So in this case, what we're going to do is we're going to take a set of features that cross many feature groups, and we're going to join them together. So this is the list of features that we want to join together. We're going to see if there's an existing training data set version for this particular training data set name. And we can see that this name doesn't match this name here, so there's a mistake there. So let's change that name there. And it says the latest version is 1. So in this case, what this will do is it will go to, this one is going to write the trained data set into Hopsworks itself. So we can run that. So this will start a job, and that job is running on Hopsworks, and that job will create a training data set with this latest version, and it will overwrite any existing training data set. The output file format will be CSV. So when I click this, it returned immediately because it was a REST call on the feature store, and the actual job is run here. So we can see if, in this case, the job was Sage, and we can see that this job is running. Now, the reason for this is because we're running this as a Spark job, and SageMaker does not internally have Spark. If you had, for example, Databricks, you would be able to run the Spark job directly in Databricks. So let's go back here. Then we have this other cell, which is doing something similar. It's taking the same data frame, and it's going to write it instead to S3. And the bucket it will write to is called SageMaker Gym. So we can start that running as well. And again, it will go back to it'll make a REST call on the Hopsworks platform to start the Spark job to join the different features together. And then it's going to materialize that training data set in the file format CSV in my SageMaker, in the S3 bucket called SageMaker Gym. Now, at this point, a SageMaker user, they might run this notebook, maybe schedule it to run before they do their training. And you would have a separate notebook that just does pure training. And I don't have time to go through an example notebook that will just work directly with CSV files or TF records or NumPy files, but that's pretty standard fare for SageMaker users. So if we go back to Hopsworks here, we can see these the jobs are, I guess, one of them, that one is not the one I was looking at, it was this one here, and this one here. We can see, for example, this Sage one has finished, and it wrote out the data set in here into our training data set, so it became available here. So we had this version 1 of the training data set, and then we have another version 2. This can also be read directly, by the way, from SageMaker notebooks. It would access this file as a HDFS file, and you would need a library then and the certificate from the platform. So we would need to export the certificate here. So from the platform, you can also use this as a file store, not just S3 notebooks. So, so in this case, we have, so in this case, this is the S3 notebook or the S3 bucket that I have, SageMaker Gym, and I just refreshed it. And if we look at the training data sets, we can see that it wrote out our training data, the CSV file, to that folder. You can, of course, coalesce those CSV files if you want a single one. So at this point, I think the time has kind of run out. I've covered what I said I would cover. We went through the feature store overview. We've connected SageMaker. We've created training data sets, both on our file system and on S3. And we might have a couple of minutes for questions. I think Moritz would have answered a lot of questions in the background, I hope. But if there's any, if there's any questions left, I'll take one now.
Hi. So yeah, there was a few questions, and Moritz did answer most of them. Given the time, I would suggest that if anybody has some further questions, we will be more than happy to answer them by mail, and we will be sending to all attendees a recording as well. In the meantime, I thank you all for attending, and thank you for all the conversations we had in the chat. Unfortunately, some were private, and some answers were public, so maybe it kind of made little sense sometimes, but overall, thank you all. And thank you, Jim, for your presentation. And I wish you all a nice evening.
Thanks very much. Bye now.